You don't want to include all of that. Maybe you have 100 independent variables, but you do not need, you don't want to include all of them into the model. Okay. And here we will consider two methods. The first one we call as stepwise regression procedure. And the second method we call as try to find the best subset method. Okay. Stepwise is easier, but best subset you need to try all the combinations and select the best one using the adjusted R-square or lowest standard error. Okay. For example, if you have 10 variables, but you would like to try the model with, get some smaller number. Suppose you have 3 variables, how many possible models you can have? If you consider only the first order model, if you have 3 variables, then how many possible models you can have?
Possible model.
Right? This is all possible models.
Yeah. Yeah. Hello, 1, 2.
You still remember it? 3 choose 1, 3 choose 2, 3 choose 3. Okay. This is when you include only one variable. This is when you include 2 variables in model or 3 variables in model.
How many people? 7. 7 sum up.
But if you have like 10 variables, then there are like many possible models. The best subset is kind of tedious. Then you have to try all combinations and see which one is the best. Okay. Stepwise is easier to select variables. Okay. And we have the forward selection, backward selection, and standard stepwise regression. When we talk about forward selection, it means that we, first of all, we fit the model with no variable at all, no x variable, okay, in the model. So it's just only the intercept term or y bar. And then we keep including one variable at a time until there's no further addition significant input the fit. Okay, so you include one at a time. For the backward elimination is in the other way around. So you start with a model with all variables into the model, and then you remove one out at a time. You remove the least significant variable at a time until you cannot further remove anything. And then stepwise is kind of like do one step forward and then do one step backward and then repeat it. Okay, until no explanatory variable can be added or removed. Okay. If you do it by hand, I would suggest to use the backward elimination. So you start with a model with all variables and then keep removing one at a time, okay, until you cannot remove anything else. But if you have the statistical package to do the job for you, then I would suggest stepwise. Okay. In SPSS, in the linear regression dialog box, there's a method here. Usually we include only independent variables, right? But we put the method to be enter. That's a default value is enter. Enter means that we include all the independent variables in the model. Okay, that's a default value. But you can select stepwise backward and forward. Right here, and then click OK. And think I have tried, I'm not sure, maybe stepwise, I guess. I'm not sure. Or maybe forward. I don't remember, I can't remember. But then what is, if you look at the output, it starts from the model 1, 2, 3, 4. That's mean that the step. They start with this model. And then the second one, they add one more variable. The third step, they add another variable. And then the fourth step is they include one more variable. Okay, so you always use the model in the last row. Okay. So this now model suggests to include only 4 variables, not 8 variables. And if you look at the p-value, you can see that all 4 p-values are less than alpha, small. Okay. So by standard, we use alpha for alpha equal to 0.05 as a standard. So these 4 variables are significant. Okay. And the last one is a best subset selection. Okay. For the idea of the best subset selection is to estimate all possible regression equations. Okay. You use all possible combination of independent variables, and this is very tedious to do. And then you choose the best fit by looking at the highest adjusted R-squared. Okay. Here we don't talk about R-squared anymore because we deal with all possible combination. That implies that sometimes we have to compare the model with a different number of variables in the model, right? So we would compare the adjusted R-squared rather than R-squared. Okay, and then we also compare with the largest log-n value and then lowest standard average. And the last slide is to sum up what we learned today. Okay, so maybe my step is quite different from the slide. So, okay, so first of all, we would like to develop a model, right? And then we kind of believe that there's a set of independent variables that can have correlationship. That have relationship with the response variable y, right? So to determine whether the linear model is appropriate, we usually draw a scatter plot of the scatter diagram. Okay, y versus each independent variable. Okay. Suppose I have the plot like this. Suppose I have x1 and x2. Okay. So the first scatter plot is x1 versus y. Okay. And I probably have the plot like this. And x2 versus y, maybe I have something like this. What are you going to do? The relationship between x1 and y can be identified by the linear, right? But for the x2, you see something. You might, in this case, you might need to try this model. And then 2x2, and then plot there, please. Okay. But actually the scatter plot can only reveal the we call it as marginal relations. You still remember marginal? When we talk about probability. When we talk about marginal, that means that we look at each variable at a time. Okay. So the scatter plot can only reveal the marginal relationship. Okay. And then you use the scatter plot to determine what should be the appropriate model for your data, right? That's the initial model. Okay, and then you develop a model, get the regression coefficients, calculate the residuals, and check the conditions on the error curve. Okay, if the model fit the data, you might use that. Use the regression model for prediction. But if there is some required conditions is violated, then you might need to try to solve the problem. Right? And also in step 4, when you develop a model, your initial model might not be the best one, right? You may try to include or exclude variable, okay, and refit the model to get the best set of independent variables.